Okay, let's get started.
Good afternoon, folks. For today, I have such a great paper, I believe, a presentation. It was very great. This is the first time I see this paper, this idea. I'm going to present it to you, but I'm not going to go to the deeply detail. I'm just going to give you what's going on, what is their goal basically, and what is the structure of the framework, and basically present the result. The name of the paper is Chain of the Knowledge, or COK. So these paper basically followed by a series of the other paper and research paper. For example, Chain of Thought, or I'm going to go through that right now. There is a couple paper regard to the basically addressing the issue of large language model. So as you know, the large language model is a very powerful, but there is also a couple side effects. One of those side effects of the large language model is the hallucination, which basically they gives you the wrong answer, which I'm saying what you want or what the model is trained, but the answer is wrong. So one of the reasons the answer is wrong because of the internal data and internal knowledge we put it on a large language model. So for that reason, a couple of researchers start doing of the, for example, bringing external knowledge to compensate of those hallucination error, to cover up and say, okay, we are going to cover up these problems. So we are going to bring external knowledge. This external knowledge can be anything. It's all about the domain. What domain your LLM is about. Your LLM is about, your large language model is about the medical. Your large language model is about the physics, chemistry, math, anything can be. But you need external knowledge. So using external knowledge instead of the relying of the internal data of the LLM. So this technique, very interesting technique. So they are going to cover up. The result is not good, but the idea is great. They are going to cover up the error of your model and the framework. I'm going to show you how this framework basically work. So this is an example of this system, verify and edit and chain of thought. These research basically before, they were before of the COK, or chain of the knowledge. So they made a couple, I'm not saying mistake, but there is a couple issue and problem with these two major things, verify, edit, and chain of thought. They use the fix of the knowledge source. They say, okay, we are going to use the external knowledge to cover up those problem and issue of the large language model, but our knowledge is a fixed. And this is not a, for example, dynamic answering to the problem. And dynamically, for example, resolving the issue. So the second issue is retrieving of the data from the knowledge is not a standard on those paper and those research. And I'm saying this is an interoperability issue. So when we say interoperability issue, it means between two interfaces cannot communicate with each other. And they just doing a research and dump it on a paper and release it the paper. I'm talking about the verify, edit, VE and COT, basically technically. So the last issue, which is very, very important, is error propagation. Propagating error using those methods. So COK, by claiming of those other and those creator of that framework, one of the interesting things is a dynamically and step by step revise and edit the query. So there is external knowledge you have, there is your LLM. So LLM gonna take the query from external knowledge and step by step make it rational. And make it rational, for example, create one rational, revise it, edit it, create the second rational, revise it, edit it, create the third rational, revise it, edit it, and step by step it's close to the final answer. That's a pretty interesting, okay? So these are three major issues the previous research basically they didn't go through that, but this paper, the COK paper, or chain of the knowledge, tried to answer and cover these problem issue also. So here is a, for example.
Can you do a slideshow? Click on slideshow. Slideshow on the right side, next to the share.
Okay. Yeah. Oh, sorry. Yeah. So comparing of the COK with the COT and V. So as you can see, there is a, for example, question is, what year was the Argentine actor who directs, for example, one movie? That's a question you are going to answer to your LLM. But your LLM is very limited. Your LLM is not knowledgeable. So you need an external knowledge to connect to your LLM. So these are all use external knowledge and connected to the LLM. But you see, these are, when you ask the question, the chain of thought, or COT, and verify and edit, these are basically gives you the wrong answer. Why they give you wrong answer? As I mentioned in the previous slide, they use constant source of the knowledge. They have an error propagation. Here is a chain of the knowledge, or COK, which that's a paper we are basically talking about. You see, this paper basically create the, if I'm gonna show you what is that step, but if I'm gonna show you right here, this framework basically create the rational number one step close to the answer, okay? One rational number one, create the basically query, refer it to the knowledge graph or knowledge source, get the knowledge, execute the query, revise it, and then it goes to the rational number two. Rational number two, same process, make a query, execute the query from knowledge source, and keep it. And rational number three. We don't have a rational number three right here, but rational number three, rational number four, and a step by step, it's obtain, get the query, and try to revise and edit, and step by step try to go to the final answer. That's the idea they follow it basically. So the detail is, if I'm going to go to the detail, chain of the knowledge, a framework that augments LLM dynamically, use heterogeneous knowledge source. So how it works? It just, at the first step, you just create the dummy rational. It doesn't matter, for example, this is a correct rational or the most correct rational. No. It doesn't care about. That's it, just dummy rational, because this is a step-by-step revising and obtaining query, executing query. And as far as these goes to the step-by-step, it doesn't matter. For example, at the first rational, we need a highly accurate. No, primary rational, dynamic knowledge, adopting a stage. It goes to that stage. I'm going to show you that stage also. The adaptive query generator, or AQG, is very important for this. The AQG basically is an interface between LLM and the knowledge source. It's very important job. The job of the AQG is creating basically query, executing query, and revising revising and editing those using, for example, SQL, SQL, or other basically the knowledge interface. So executing and generating query to obtain knowledge and revise and edit first rational. This is not related to the first rational. You can use it second rational, third rational, or n rational. It all depends what you are asking about into your model. Applying it to the process to second and third rational, chain is rational to find final answer. Do you understand what I'm saying? Anybody, any question right now? Any question?
Yeah, if you can move to the previous slide.
Previous slide.
Yeah, here you have mentioned error propagation. I don't know why my voice is recording.
Edit. You are talking about the edit and revise?
No, I'm talking about you have mentioned that there is error propagation in it. But I don't see it as error propagation, it's just basic error. How it is how is the error propagating?
So error propagation, when you basically create the first rational, your first rational definitely has an error. Okay. So this model basically claim, I didn't use that model and I didn't use that framework, but they claim that, and their claim is basically logic. They're claiming, okay, our first rational, we got it first rational, we revise it and edit it. This is a very, very important steps. So those revise and editing, preventing the error propagation to the next step and next stage, because they use rational 1 to generate rational 2, and they use rational 2 to generate rational 3. So rational 3 depend to the rational 2, and rational 2 depend to the rational 1. If you have an error on a rational 1, that error going to propagate to all, for example, rational 2, 3, 5, n. All right. So what they did basically, they use revising and editing. Okay. Use revising and editing. When they get the rational 1, revise, edit, make a clean up rational, and then use that rational, go to the rational 2. When you get a rational 2, make a edit and revise, and then go to the rational 3. So these basically, again, I didn't run it.
My question was a little bit different. What you were saying, I get it in the context of chain of knowledge. But can you go to the previous slide? Slide number 2.
Slide.
Yeah, here you have mentioned problems and issues, and I think chain of thoughts and verify edit. Here you have mentioned error propagation. So is the terminology error propagation valid here if someone doesn't know the chain of knowledge?
This error propagation related to the COT, the chain of thought, and verify and edit. This is not related to the COK or chain of knowledge. As
No,
I say, as I
if you
mentioned,
know chain of knowledge, then error propagation seems to be a good, seems to be the terminology that should be used. But you are mentioning the problems and issues in chain of thoughts and verify and edit. Then you are using error propagation. That doesn't make sense to me.
So, Yash, let me step over here. So, I don't know. So let me just try to see if I can answer your question nicely. Error propagation over here is not a learning mechanism. Let's just separate that out. Okay, you are not teaching your model to understand or to capture the error and then revise or update it. Error propagation over here is like this. Suppose you do a chain of thought or you do any sequential prompting mechanism. If your model tends to find anything wrong in the middle of your sequence behavior, sequential decision making behavior, it starts propagating that errors in the future prompts. It has no way to correct it. So if even if you say, let's say I do chain of thoughts, or you do zero shot prompting, or you say few shot prompting. Let's say you do few shot in a sequential manner, right? First few samples and then few samples and then few samples. If if there is an error that the model identifies or captures, that same error gets propagated to the next stage as well, right? Because there is no correction mechanism in the middle. So assume this, that you are doing chain of thoughts, but in the middle you are looking at each and every step and you're correcting it. That's what they're saying as it's just, I would say, it's a way to reduce the errors, which tends to get magnified if they go till the end of your prompts, right? So that's so in artificial intelligence, right? We used to call it branch and bounce, right? So there is a very nice strategy, and that was one of the criticisms that I had about this paper, was they did not use branch and bound. Branch and bound strategy itself tells you that there is a cost mechanism when you do sequential decision making in some sort of trees, right? So let's say that same query about that person from 1925 to 1941. The first thing is that, is this person's movie less than this particular year or is greater than this particular year? Is that movie within that bounds of that year or not? And then who are the people in that particular movie? What is the plot of that movie? Right? Who are the people in that movie? And then when was the movie released in specific? So there are certain series of questions that the model can generate next to this question. So the idea is that whenever you tend to find a particular box where you think that you're going beyond the possible correct knowledge that you have retrieved, you bound that particular outcome. You don't let it branch further. If you keep branching things till the point it is absolutely correct, you stop at the point when it is no longer required, right? So a branch and bound strategy, good old, I would say good old because it was good, but it is old. Good old artificial intelligence. There is a very legitimate technology or an approach or an algorithm called branch and bound. And I would suggest that doing this kind of a scenario using LLMs is perfectly floating away because of the world is talking about LLMs, but the approach that they have defined in this paper is very similar to branching. Right? There is a utility function, there is a branching function. If your utility function is not satisfied, you stop. You don't let it flow. But if the utility function is satisfied, you keep branching it to the point where you get the answer. It's a very much nice strategy. I think that's what they have been doing.
Branching bound, I didn't hear. Branching, what is
branch and bound. So there is, if I want to show it, let me open over here. So there is, if I say Wikipedia, branch and bound. So there is a very nice approach in solving optimization problems and algorithms called branch and bound. Right. So you can actually look at it. The interesting thing is over here is you keep doing branching as long as your utility function it is satisfied. The time your utility function is not satisfied, or it is kind of, let's say you have 5 rules, and let's say you put a threshold of 50%. If any rule above 50% is not being
Sir,
followed.
your screen is not being shared.
Yeah, you can type Wikipedia branch and bound, Yash, to study
Okay,
it.
okay. I thought
It's
you.
a pretty old.
Discrete function or a continuous?
It's a continuous function.
For branching and bounding.
Your branching is on your discrete set, but
Oh.
your optimization function will always be continuous. It will never be discrete,
Hmm.
right? So that was my first criticism to this paper.
Yeah.
That okay, this is pretty good that you took LLMs and you're dancing on that, right? And I'm pretty much recording. I will put it on YouTube as well. But the thing is that one should be very sensible to what's there in the literature in the artificial intelligence. And whatever they have done is very similar to branch and bound. Yes, Nilanjana, you have a question.
So how is the goal of this paper different from that of that?
We will come to that. I saw your comment on chat, in the chat.
Okay.
Yeah. Okay, let's go ahead.
Okay. So here is a chain of knowledge framework. Here is the structure of the COK. There is a three separate, basically a structure. Yeah, the reasoning, which is right here, and the dynamic knowledge adopting, and the answer consolidation. The answer consolidation is less important. I'm not saying not important, but the main body of the COK, I believe that's dynamic knowledge adopting, which is number 2. And you see, these are separate, basically knowledge. I believe they use the factual, medical, physics, biology, but and these are basically data set. These are not spatial or specific things. They use rational number 1, rational number 2, from rational number 1 to rational number 2 knowledge retrieve, and goes to the final answer. Also, yeah, it's pretty simple and clear. To me, if you have any question, just let me know.
So what have they considered? What is the definition to them? For them, actually, what's the definition of rational? What is rational to them?
I'm saying the rational for them, I believe that's a statement. To me, when I read the paper, it means to me a statement. For example, there is a specific statement, get it from COK, and basically they have a reasoning in their framework. I'm going to show you their reasoning, basically AQG. Also, I'm going to go through that.
No, what is rational to them?
Rational
is
is
a
a
statement.
statement. The English is statement.
And what is rational to human beings? What is the definition of rational to human beings? Sriram.
Logical.
Exactly.
Facts.
Huh?
Facts.
Facts. Anyone else? Jinendra, Nilanjana, Yash, what is a rational to a human being? If I say Reza is a rational thinker, what does that
Something which is sensible.
Okay, that means you make sense.
Yes.
right?
Like
Yes.
which adheres to the
Which
rules
adheres to the rules
of a common
of a
accepted
common
grounding. Let's say
accepted
physics is
grounding.
a
Let's say
common accepted
physics is
some
a common
laws, so
accepted
that's
some
rational to
laws, so
think.
that's rational to think.
Okay,
Something which
I
is
would say
explainable.
logical.
I would say logical.
okay. So there is a logical reasoning or a logical sense.
But the rational is not fact. Rational can be changed in the future, or basically can be revise it and edit. This is not a fact. You cannot revise and edit fact or factual statement. Is that correct?
Okay.
Because the system right here is a revising rational. I don't believe they means the rational is a factual things. The rational to me is a statement. If that statement is a logical statement, can be true, can be false.
Yes.
And for that reason, we need a revising and editing.
Okay, let's just step back. What did you just say? Rational is something that can be true, can be false.
Yes.
Correct? That means if there is two possibilities that I'm talking about, true and false, both of the possibilities can happen in rationality. Does it make sense? If let's say there are three possibilities occurring, let's say yes, no, maybe, right? Then the model might say that okay, it can be true, it can be false, and probably I don't know. I don't have the confidence. If I say, let's say 5 labels are there, the model generates 5 different possibilities. Right?
Yeah, true, false is just examples.
Yeah.
Yeah.
So true and
It
false
can
is
be a lot. Yeah.
right, exactly. So within that domain of that question, there can be multifold answers to that particular query.
Definitely.
Did they demonstrate this?
Surely.
Did they demonstrate this? That the rationale to them is a sentence. They did not check whether rationality or the rational sense is confined towards the different possibilities, or is it capturing those different possibilities that might arise based on the different chunks of the information that I retrieved. So if you look at this, they are doing reasoning generation, rational over here, and then they're doing the knowledge retrieval. If this is wrong, this is wrong.
Okay, I agree with you, but
Do you think
as
that
far
knowledge
as
retrieval?
they have, I believe, as far as they have some error detection correction process, I believe they converge. The final answer will converge to some sort of the correct answer. I'm saying, for example, 50-60%. I'm fully agree with you what you are saying right here, but the edit revising, error correction, and error detection correction, which is very substantial things, I believe, in their framework. What do you think?
Come again? Last right? Last.
I'm saying the error detection, the most powerful things in this framework, what I see is first of all is a reputation, because it's gonna retry.
That's not a novel thing, right? Repetition is not novel at all in the research.
Okay, so
that is a learning phenomenon.
All right. How about the error detection correction?
Error detection and correction is as okay. Error detection and correction. Why do you have errors?
With regard to the COT and verified edits.
Yeah. So if you look at the first block, the errors will still occur even in this framework, because rational is not rational of the knowledge, it is a rational of the model. This rational is, if you read it, if you understand correctly, this rational is coming from ChatGPT, not coming from the knowledge.
Okay, so yeah, maybe, but their data sets, I don't know where is the source of the knowledge, but they mentioned the source of the knowledge. Yeah, you see the ChatGPT right here.
Yeah.
Maybe, but
who all agree with me that rational should be after you have done the knowledge retrieval?
I'm assuming, okay, the rational
They
is
showed that as corrected. rational one?
Kavi?
What do you mean by that? So they are getting the rational from the knowledge as well, which is the corrected rational one in the middle.
Yeah. So you correct this rational over here, right? So this rational that they start with is not the rational of the knowledge, is the rational of the model.
Yeah, but they are not saying that that rational one is from the knowledge.
Exactly. So if
So
I
you mean the terminology is wrong here?
exactly. So I don't think so that's a rational is the right word. It's just a hunch. Or it's just I would not consider it as a rational because rational means that you are checking all the cognitive possibilities of that answer and then coming up with a solution or coming up with an outcome.
Okay.
Right? Like let's take an example, right? If I ask you this question that can I have a purple color apple or can I eat a purple color apple? Right? First of all, you have never seen a purple color apple. Right? So you will say that probably you can't eat it. And then I do the retrieval of multiple knowledge that will help me correct, oh, there's a possibility that someone has actually painted that apple with a purple color. Right? And or something of the sort. Or this is a showpiece. And that's why you cannot eat it. So you're improving your outcome, your generation. But your rational in the first part, rational when I say if a person is rational, that means he already had that graphical structure to examine that, oh, purple color apple is most long is actually not seen much. Oh, purple color apple, it is mostly a showpiece. A purple color apple is probably an apple that might be used as a what do you call it? As a paperweight, right? Or something, but it is not eatable or it's not edible. So these possibilities you construct, that is your rational.
Mhm.
Your rational is not a sentence or a statement. It's actually a graph. Right? In probability theory, we call it belief graphs.
Mhm.
Right? That's rationality. Right? So now let's say if they took about the reason I say that the reason I criticize this point of rationality over here is because they took reasoning generation and knowledge domain selection. So that means they selected the knowledge domain and then they started reasoning on them. So they won't have only one rational, they will have series of rationals.
I think they are taking a single path from the graph as a rational.
Exactly. Then again, then it becomes a branch and bound problem. You get my point, what I'm trying to say.
Yeah. About the definition of the rational and what is the rational is.
Let me tell you why I criticize this one, right? Let me share my screen a bit for a minute,
Mhm.
and then I'll come back to you, which is over. Check this one. This is a rationality from the people who are actually reasoning people. This is what they call it. Giraffes. So there's a giraffe. Which animal lives? Which animal gives live birth? Giraffe or spider? So they looked at giraffes give live birth. True. Spiders give live birth. True. That's a false statement. Then they examine over here. Giraffes gives live birth. Spider gives live birth. Mammals give live birth. A giraffe is a mammal. Rodents give live birth. A spider is a rodent. Rodents are mammals. That made them believe that that's what rationality is. That is not rationality.
Okay. Yeah, makes sense. Yeah.
You see what I'm trying to say
Yeah,
over here?
definitely.
The reason they say that the reason I'm saying is because rationality to them was wrong, because they said that we are doing reasoning generation, and second, we are doing knowledge domain selection. That means if I have a question on an NFL, if I have a question on a soccer, if I have a question on a movies, then I know the domain that I'm talking about.
Mhm.
Right? So, and I think in that particular, so this thing, again, let's say over here, this is what they considered as a belief graph. The belief graph is all the possibilities that your model is capable of generating. And each possibilities is equivalent to a sentence. Right? You cannot have one rationale that you iteratively correct. You have sequence of different reasoning operations that you evaluate, you examine each of them, and then you start repairing them through your retrieval processes.
Entire that is
The rational process.
Okay.
Rationality is a thinking process. It's not a sentence generation process.
Yeah.
Right? Let's start again. You can share the screen.
Okay. So here is a component. I just missed one component right here. The reasoning preparation stage consists of the two, the reasoning generation and knowledge domain selection, which we talked about, and say, okay, it is not created rational, and this is not a rational. So, but the heart of the system and framework is a dynamic knowledge adaptation stage. That's basically knowledge retrieval, query generation. This is a very important SPARQL, SQL, or natural language sentence because we have a different, basically, data set and knowledge source. So each knowledge source interface and talk with the different language. For example, you have one knowledge source is talk about the SQL, one knowledge source talk about the SPARQL, and another knowledge source talk about the natural language sentence. The query execution, this is I don't know if you folks have familiar with the SQL. It's same as a select. When select, there is a, for example, condition. If you have a query or SQL experience, that's pretty similar to the query execution. Rational correction, as I mentioned, the rational correction is a mechanism to prevent error propagation to entire systems. So the next rational generation, as I mentioned, you create a one rational. You have to be careful about the definition of the rational. Create a one rational, revise it, edit it, make a second rational from that one, go to the knowledge source, retrieve it, and make a third rational, make a fourth, and the next rational generation also is a beauty of the dynamic knowledge adaptation stage. Here is a main experiment result. I'm not going to go to the detail what they did. Basically, you can go to the paper and read the number. These are only number, but as you can see, COK right there has, for example, 63.4% rather than, for example, COV on a different data set, factual, medical, physics, and biology. As I show you on that picture, these are basically knowledge base they use. Yes, they use 3 shots, 6 shots. These are basically experiments. I don't think we need to go through that. And these are just results.
Okay. I know these are just results. What do you think?
What I believe, right here, the COK is a 63.4% rather than, for example, WE, which is 60. The accuracy, the most important, the exact match EM is a little bit better. The accuracy also a little bit better, but for a 6-shot, disappointing. We have a 58.5 rather than, for example, 57.2. It is not improvement. It is something, but not significant.
This is the case for
These data sets,
the data set, right? Favor.
yeah, they also use basically the task data sets.
Why the performance got decreased for these data set only? You see, if you look at the other data sets. Somehow.
I didn't go through the data set. I have no answer for right now. Would you please repeat your question? I didn't.
So she's saying that why there is a improvement in other data set except fever.
From 6-shot to 3-shot.
I don't know. I have no answer for right now for this. I didn't run the framework, but they use different variety of the data sets.
So first thing I would say when I saw this result, I knew, like, I know the first 3 data sets. So fever data set is called the fact verification data set, right? That's why the term fever, right? So fact verification, they say is that suppose I say that Barack Obama is the president of Germany, right? And if I find a slightest fact that verifies the sentence, then there's a possibility that LLM will say that 1%, 2% chance there exists that Barack Obama is the president of Germany, right? So fact verification data set is about then when they actually looked at the facts of a particular sentence and they have a link where you can verify it. You let the model generate its answers by its own knowledge and then corroborate with that retrieved knowledge. That's what they put it. That's why they put it as a COK problem.
And it's based on what you mentioned, it means the data that we have in that data set is fixed, right?
Exactly.
And when we use it, when it's fixed, it's different from one sample to another.
Exactly.
And we cannot figure it out the pattern from 3-shot or 6-shot. That doesn't make
So
sense.
moving from 3-shot to 6-shot is a standard behavior of any machine learning problem. The more samples you give, the merrier it is, right? It's been proved by Hopkins inequality. It was proved by pack learning by Leslie Valiant. So this is something not new to me, right? If I do 10-shot, they will definitely improve it further, right?
But I was talking about the past.
Right.
part of the
So
case.
now
Talking
in the
about, yes.
fever case, right now, if you look at, let's say we do a rational generation and then we are improving upon it by multiple knowledge retrievals, it's a whole lot of a process, right? Yash can tell us right now that just running one retrieval consumes a lot of time, right? It's a time intensive because it's an IO operation. Your model is stopping itself, retrieving the information, encoding it, then putting it to you, and then you're generating it further. It's a long, short process. The amount of time that goes in doing this and the amount of improvement that you're getting is small. Right? So if you see, right, 57.2 to 15.5. Right? That means that there are only few cases of few samples in the data set. Right? So there are only few samples that exist in the fever where your model is getting wrong. Right? Okay. So that's why I like WebEx. I can mute anyone anytime. Right? I do it in the meetings. If someone is utter rubbish, I just mute him or her, whatever it is. Okay. So see this thing. So this tells me that there is only few set of samples where there was error and you could make an improvement over there. Right? And in this context of hotpot QA, again, the same situation. Hotpot QA is a question answering data set. For every set question answering, there is a link to it. Right? So you try to check with that link what is the correct answer for this. Right? Issue will arise. Let's say I can very much break this chain of knowledge system. Yeah, Reza. And how would I do it? I will take the fever data set and I will replace at every Wikipedia query with 5 to 6 Wikipedia queries over there. Links. Very similar to each other, but 5 of them. Now you select from them. Right? Now, let's say I make fictitious Wikipedia pages and I put them over there. It is very difficult for the model to figure out which is the right one, which is the wrong one. Right? So these selection, this improvement over here was relatively very small, amounting to the amount of effort that is being involved in this work. So that was one of my major concern to this, that I'm still 60%, even despite of having so much efforts. I'm still 34% despite of so many. Is COK applicable to real world? Probably not. You won't buy a system with 34% accuracy, irrespective of whether it is chain of knowledge or chain of thought or whatever it is. Right? Similarly, you can do an MDC, or you're doing a medical question answering system. Would you buy a system with 70% accuracy in a medical question answering system? No, you can't. Right? Similarly, you see physics, you see biology. There is some sort of improvement over here, and that's what's interesting to me, that the reason is biology does not have mathematical equation. This data set has removed all the mathematical equations that exist. If you replace biology by genetics, this accuracy I'm pretty much sure will go down. Because genetics is mathematical. It is no longer just textual data. Right? So this experiment, though they have proved something, but it was tactful. It was a really tactful way of picking up the data sets for proving your point.
It's highly SQ and rely on it.
And I would say that, like, pick their system and use quantum computing. Ask the model to fill up the answer for quantum computing. Quantum computing is a heavily math intensive problem. You won't, even if the related work in that paper, you will find mathematical equations in that. Right?
Yes.
And the LLMs do not understand, or even if you do the correction mechanism, they don't understand mathematical equation, not at all.
Makes
Right?
sense.
So you can very much see over here, right? See the performance over here, see the performance over here, see the performance over here. That means whatever you're doing in your space, you're only emphasizing, you're doing very well on the textual data set. Whenever you are facing numerical values, you're going down.
Yes, that's correct. Yeah, from physics.
And
yeah,
they did not explain this in their paper.
Yeah, they didn't. I didn't
Exactly.
see it. Yeah.
ICLR.
Really?
Yes. I wanted Ali to present specifically, because this falls into his purview.
Yeah.
Whatever you're saying, that explanation, I'm generating 3 explanations. You're not generating 3 explanations. You're generating 3 rationales.
Correct.
Right? Which of the rationale is correct? That becomes your explanations. That's the reason I shared this paper. I know who to pick the paper.
Yeah, but I didn't select it to present because if I present that, it will take away my focus.
Yeah, but you have to present it. You have to present it.
Yeah, but the correct one.
Yeah. But the reason is that whenever I share with you guys, I read that paper critically by myself as well. Right?
Yeah, definitely. So, yeah. So even one of the critics I had to that specific number and result is why the margin of the, for example, COVE or COK is, for example, look, 67 to 70 is not too much. Even you have error detection, correction.
Now,
Even
if
you
you
have
look at, if you just simply replicate this results and replace accuracy by exact match in MMLU and medical MCQA, you will see that it is not even crossing 10%. I'm betting on it. I'm
10%.
Exactly 10%.
Okay.
Open review. Just looking at the CDC one.
Yeah. Okay, so this was my thought process. So whenever you read a paper, guys, mind it, it's just not a storybook that you're reading. Tear that paper apart and then read it carefully.
Definitely, yeah.
Right? A reviewer is not a reader.
Myself
It
is a
is a-
chart reviewer,
Yeah.
but
You need to be critic.
yeah, you know, one of the fascinating things I never see connecting the knowledge, especially KD or knowledge graph or knowledge source to the LLM.
Yeah.
This is the first paper I read about the connecting these two.
Yeah.
Very interesting.
I think that the biggest selling point of this paper was the right choice of terms. People have done chain of thoughts, people have not done chain of knowledge. So they pick the word knowledge and they put that in the paper. Secondly, there is a huge rise in rationality in AI literature in the past few months. Right? I would say 7 to 8 months, there is a huge growth in rationality. Looking at rationality in the LLMs, they hit on that by the rational generation. Third thing, people were only talking about Wikipedia or let's say putting a dense message retrieval and everything of the sort, right? Using the RAG, retrieval augmented generation approaches, which is given a query, I will put that query into an embedding, I will pass that embedding into my dense message retriever, retrieve the documents, put that document to the query, give you the answer.
Mhm.
Right? That has been already been the case. What people have not done is Sparkle. They introduced Sparkle in their work. Now, Sparkle is nothing new. Sparkle is a language for retrieving the information from knowledge graphs. Right? Now, the question is that now, not everyone, now they did not report in the paper how much improvement did they got by using Sparkle. Did they report it?
No.
Exactly. Second thing, SQL is very similar to Sparkle. They put that Sparkle and SQL. Did they report the result? No. What they reported in the result was through natural language sentences, which is very similar to dense message retrieval and people understand very well. Right? So three things. So what I'm trying to say that they embarked on the things that people have not touching upon. Right? That's what they put together in a paper. Now they knew that when they use physics, or domain, or medical domain, or biology domain in terms of exact match, they will perform poorly. That's why they did not report EM for those domains. They report EM only for the hotpot QA.
There was all of them.
Did they report?
Even the table that.
Yeah. So it is EM only for this, not for all other cases. Whereas for other data set, you can very much calculate the EM.
Exact match.
Exactly. Right? If you do the exact match on MMLU of physics, you will hardly cross 10%. That's what I was betting.
Is that I didn't see exact match that as a metric. This is the first time I see
Exact match is a very hard, very brutal metric in natural language processing. The reason is because you're putting the exact match over there.
Also, it's in cybersecurity.
Yes. And more critical domains, you need to have exact match. That's why the paper that we are writing, the reasons paper, right? We did F1 score, we did blue. Blue is very similar to exact match. Right? And we are being trashed over there. Perfectly fine. We are happy to be trashed, but we should not hide results that are trashing you. Right? So that's what one of the things that I opened up in this paper. That they did talk about knowledge, because knowledge is something that not everyone has talked about in the chain of thoughts or chain of reasoning or graph of thoughts or so and so forth. Second thing, rationality is very interesting. That's why they introduce the word rationality, and I think that's the word you should buy in, right? Anything that is not shown to the user but a model generates is, I would say, is a nice way to say it as a rational.
correctly, you mean the reason behind the action.
Right.
But in here, they didn't consider measuring the rationality. I mean,
Exactly.
because it's different from, if we can say, from model or agent, AI agent, it's different from one agent to another because it's based on whatever the agent knows.
Exactly.
Not based on the other sources, right?
Yeah.
So they didn't consider, I'm not sure if they consider something like this.
No, I didn't see. You see,
I mean, for example, I know you know all of the details of something, so you make reasoning, right, in a way which is different than me that I know half of those information that you know.
makes sense.
So that means that if there is an
Yeah.
expert,
Yeah,
he knows multifaceted object of that particular query.
Yeah.
He examine all of that turf and then give you a rationale. If you are a half expert, you only look at half of it.
and we can, and from this point,
Yeah.
I'm not sure. I didn't read this paper, but if they consider something else like this, if you reason based on whatever you know, right, and I reason based on whatever I know, both of us are correct. Because whatever I have, I reason based on that. I'm not sure. Based on the slides, they didn't consider this.
I also didn't see.
Human evolution?
Uh,
Human
No, I'm
evolution.
talking about the definition of rational. I'm talking about the definition of rational that was mentioned.
Yeah.
But in another.
Okay, this is an experiment. The models, the knowledge source they use, the task baseline. The baseline is a standard COT, another type of the COT which researched by another researcher and verify edits, which we talk about it. ChatGPT 3.5 Turbo, that's a model of the LLM. Also knowledge source, the medical domain, physics, biology, fever, a couple other MMLU. I'm not pretty familiar with these knowledge source. These are pretty. Is the
They are not
final-
knowledge source, they are data sets.
It is knowledge.
No, they are all data sets.
All data sets.
The knowledge that they're using is Wikipedia. That's it.
Yeah. As far as these are not
And this
kind of-
they call this another interesting term that they use in the paper is a multi-knowledge source when they are not using multi-knowledge at all. They're only using Wikipedia.
Mention the multi-domain source.
Exactly.
Mhm.
Right. So this choice of words is very, very important in your paper writing. What you're doing, what is the word you're selecting, right? How are you are different from anything that has been already been done.
So yeah, this is show the result, and they claim in their paper they got the 4.2% improvement on accuracy, 3-shot fever. This is I'm saying they just sell this number in their paper and say, okay, we have a great improvement, we have a 4.2%. Also exact match, you see 2% for a COK hours right there. And these are accuracy of the COK and COT, basically, with the medical and biology for a 3-shot. Any question? I believe that's the last slide.
Did this show what if they use flashcard only? What if they do flashcard plus up to date? What if plus flashcard up to date plus science QA?
That's one of the main question of that paper. They never go through how they use it. I didn't understand the flashcard basically.
So if I would say the following. Let's say I take one knowledge source and my amount of rational time is 100 rationals that I'm generating. If I use two knowledge sources, my rational time went down to 60%. If I do 3 knowledge sources, my rational time goes down to 25%. That means my model is not only looking at different rationals over the time, but it's understanding where not to go. Right? And it is using multiple knowledge to curtail my number of rational times. The amount of time I'm generating rational. Because the amount of time I'm generating rational, right? That means that is a time when I'm not getting the correct answer.
That's correct. Yeah.
Right? So the more number of rational I'm generating, that means the more number of time I'm getting wrong. Right? So
That's a
did they show?
propagation error.
Huh?
That's a propagation error.
Exactly. How much is the reduction in the propagation error? Did they talk about it?
Say that they got 2.1% improved when utilizing both flashcard and up-to-date.
And after that,
And they compared it with the only using flashcard.
so I would say that a very more intuitive method, right, to evaluate this paper would be that if I have one knowledge sources, I would definitely have more number of iteration of rationals, right? Or I would have relatively higher. But if I have more and more knowledge being added, I'm using multiple knowledge sources to correct myself intrinsically, right? Let's say I tell you that answer this question by just looking at chapter 1. When when looking at only chapter 6, when a part of the answer also require you to read chapter 2. So if I add chapter 2 to you, you should find less time in coming up with the right answer, right? And if I just give you an access to chapter 6, you will take more time because somehow or the other you will try to speak into chapter 2 to come up with the right answer.
Mhm.
But if I give you chapter 2 straight out of the box, then you should find less time, right? So that's a hunch that I'm trying to say, right?
Yes, that's correct.
So
Makes
that
sense.
would have been a more intuitive and understandable evaluation of this paper. That is there an amount of rational generation going down when you're doing a multi-query thing. Now, if your rational time is not going down, that means whatever you're adding in the multiple knowledge sources, you're still doing a sequential query across all the knowledge sources. If your rational time is going down, that means your query generation is federated across all the knowledge sources together. A federated query is what? A federated query is a query that goes over all the databases together at the same time. And a sequential query says, I pick information from this database, then I will use another database, then I will use a third database, and so on and so forth. Right? So that's again an architectural choice on the chain of knowledge.
Yeah.
So it's just not the data set, it's just an accuracy I'm very much fascinated about, or the exact match. I want to look at what is architectural choice a person picks when they talk about chain of knowledge. And I think the chain of knowledge by the definition means sequential checking of the databases. I check this database, then I check the another one, then I check the other.
Mhm.
Have a look at this in depth, Harley. Read this paper and also the rationality paper, because those do not read it for your implementation perspective. Read it to position a paper in the right way,
Yeah, sure.
right? Because the thing is that it's not about
Different than explanation. Right?
yes, it is different from rational explanation.
Here they trying to do the right to do the right action, right?
Yeah.
But in explanation, we are trying to say why this.
But that's rational.
No, but in fact, it's not important if those information from the input is correct or not.
Okay, so let me ask you a question, right, Ali? Right, I'm asking a question on this case. In this case, that do you know about the quick sort?
No.
The quick sort algorithm.
Okay. Yes.
Do you know about the quick sort algorithm?
Okay.
What came into your mind when I asked you this question?
The value of the
Exactly, that's your rationale. Now, once you understand that and gave me an explanation, that's an explanation that you've seen. Because you thought, you made the picture, you went through multiple steps, then you said, that, oh, now this is the explanation I should give to Max. That is an explanation. Whatever thing happened in the middle is your rationale. That is not giving up your outcome. That is helping you to construct your explanation.
That's
And your
right.
explanation is always one and is always correct and precise.
Makes sense.
Got the difference? Okay.
I think makes sense, yeah.
Right?
Yeah. Anything else? Sorry. Any question, any concern, any comments, any idea, opinions? Folks?
Okay.
I-
Lanjana, any question? I think you had a question on RAR, and I think that's perfectly fine. RAR was not a part of this paper. That is another point worth considering.
We have the metacognitive problem also right after seeing it.
Exactly.
So how it's different from that?
Absolutely. Because it never reached to a conference paper, they did not include it in the. Yeah, that's a valid point, Ayush. Right? Metacognitive prompting has a self-correcting mechanism. You can correct your outcome before you move to the next thing. They have a self-correction mechanism, which they did not include in there.
Yeah.
Because that paper was in archive, people don't read archive paper much. They only read survey papers. Right?
Do you know about the self-revising or self-editing techniques or?
Yeah.